Welcome to another edition of Comet Algebra. This video is for Algebra 2, Chapter 5, Section 6, Completing the Square. So we're going to start this video by doing a little review from Algebra 1 because it's been a while since you've done any completing the square problems. We use completing the square method when a quadratic cannot be factored and we can't solve it by taking roots because we have an x term. So this is just another method that we're learning in all the different ways to solve quadratics. So I wanted to start by visually showing you with shapes what completing the square looks like. So if we let this x squared be represented by this red box is going to measure x by x. So the area of it, this shape, is x squared. So that represents this part of our quadratic. And then these blue rectangles over here measure x by 1. So the area of this blue rectangle is x, as all of these are. So these 6 blue rectangles represent 6 x's here. And when you complete the square, you pick these blue rectangles up, and I'm going to set them next to my red box here. So you'll notice that I took the 6 blue rectangles, I split them in half, and I put half of them here, 3 of them here, next to the x squared, and I put 3 of them below. Because what I'm attempting to do, I'm actually attempting to build a square. So now to complete the square, the question becomes, how many of these black squares represent 1 by 1? So these are ones. How many of those ones do I need here to finish filling in and build a square? And since this measures 3 by 3, then I'm going to need 9 of them. So there I've put in the 9 black squares representing 9 ones, and now I have built a perfect trinomial square. So to complete this square, I need to add 9. Now let's just talk about what a trinomial square is. This first term is a perfect square, and the last term is a perfect square. And this middle term has to be the outer product plus the inner product. So part of this process is you must know how to factor a perfect trinomial square. And if you look at the factors that multiply to give you 9 but add to give you 6, it would be x plus 3 and x plus 3. And we're always going to factor these trinomial squares by writing it as x plus 3 quantity squared. A shortcut to this, if it's helpful, this first part of the factoring is the square root of this first term. The square root of x squared is x. The last part of the factoring is the square root of this last term. The square root of 9 is 3, and whatever sign we have right here becomes this sign. If it's a positive, this is a plus. If it's negative, it's a negative. And of course, it's a perfect trinomial square, so there's 2 of these, so we just write it as x plus 3 quantity squared. So this is just a visual of what completing the square looks like, a visual representation of what a perfect trinomial square, it really truly is a square. So we're going to put the steps in words here because some of you like that. The steps to completing the square. First of all, you write the equation of the form. You put the x squared term first, then the x term, and then I usually leave a little space like this. We'll put the x squared term, the x term, leave a space, and then put your constant on the other side. And then this blank here reminds me that when I complete the square and I add something right here, you have to add it to both sides, of course. Now this is the algebraic piece of what we did with those rectangles. In our example, the b was 6. We took those rectangles and we cut them in half. 3, and then we put 3 on either side of that square. And then we needed to fill in a 3 by 3 space, and then that's why we had 9 of those little squares. So here's algebraically what we did. We took the 6, we cut it in half, and we got 3, and then we squared the 3 to get 9. So this in this red box represents the algebra. You take the x coefficient, divide it by 2, get that answer and square it. And that is what you add to both sides. You add it on this side and this side. Then the square is complete. Now we need to solve it, so we factor the trinomial square, and then we will do the steps of solving by taking the square root of both sides. So let's look at some examples. All right, we'll start with these two. We are just going to complete the square and factor them. In the next examples, we'll actually finish this and solve it. But let's just learn this one step at a time. So we need to figure out what do we add right here to complete this trinomial square. So if you grab the x coefficient, it is 8. We divide that by 2 and get 4, and then we square that to get 16. So completing the square, x squared minus 8x plus 16. Then we have to factor it. So the square root of x squared is x. The square root of 16 is 4. Right here I have a minus sign, and we know there's 2 of them because it's a perfect trinomial square. So factored becomes x minus 4 quantity squared. Example 2. Again, we're going to go through the same process to figure out what do we add here to complete the square. So we take the x coefficient, in this case the y coefficient, which is 5/3. We are supposed to divide this in half. Well, if you remember from your elementary school days of dividing fractions, we don't really divide them. Dividing by 2 is the same as multiplying by a half. So the way you take 1/2 of 5/3 is you multiply it by a half, and you get 5/6. Then we need to take this and square it and get 25 over 36. This is what we add to complete the square. And now we have to factor this. The square root of y squared is y. The square root of 25 over 36 is 5/6. And right here we have a plus sign. And since there's 2 of those, it's squared. So now we've worked on completing the square and factoring. In the next ones, we have to do the next steps and actually solve. So the directions do say solve by completing the square. So I'm just going to rewrite this and give myself a little room here where I need to complete the trinomial square, and whatever I add to that side, I must also add to the 15. So let's do the algebraic steps. We take our x coefficient and cut it in half. We get 5. And we square that to get 25. That is what we add here to build a perfect trinomial square. And since you added 25 on that side, you must also add it on this side. So now the next step says we're going to factor this, and we're going to go ahead and add the right side of this equation. So factoring this becomes x plus 5, quantity squared. And then when you add these two, you get 40. Now we learned in the previous section, when we have this squared isolated, we take the square root of both sides. So that's the method we're going to use right here. Square root to this side, square root this side. The square root of these parentheses squared is just what's in those parentheses, and we do need to add the plus minus for the square root of 40. So what we have left to do here is subtract a 5 from both sides, and we got to check this 40 and for any simplifying we can do, and we notice that there is a 4 in it, so we get 4 times 10. So I'm going to subtract a 5 from both sides and pull out that perfect square of 4, which is 2. I will allow you to write this plus minus as long as you understand that this is 2 answers. It's negative 5 plus 2 square root 10, and the other answer is negative 5 minus 2 square root 10. Sometime down the road, when we're doing real life problems, we won't be asked to do these in their decimal values, and so we'll have to make sure we understand how to do the plus minus. These next two examples kind of ramp up the difficulty a little bit. When there is an x squared coefficient other than 1, it can't be there. We want to complete the square, but we need to get rid of this coefficient. So we're going to divide everything by 3. And of course, this does give us fractions to work with. So let's rewrite this. We have our x squared then minus 13 thirds x, and then I'm going to leave a blank for completing the square, and then we'll bring our 10 over to the other side and leave the same blank there. So now we follow the exact same steps, but they're just, like I said, a little more challenging with fractions. So we have this 13 thirds, and you'll notice I'm ignoring this negative sign. The reason is because when you square it, it's going to be positive anyway. So first we want to take half of this 13 thirds, so we multiply by 1/2, and we get 13 sixths, and then we need to square that. 13 squared is 169 over 36. So this is the fraction that we're going to add to both sides to build a perfect trinomial square. We factor the left side, and then we will be adding those two numbers together on the right side. So when we factor this, it becomes x minus 13 sixths quantity squared. In order to add 10 and 169 over 36, we need to get common denominators. So I just realized I had made a mistake here, so I hope you caught it. I should not have wrote 10 here. This is really 10 thirds. Sorry about that. But we do need to add 10 thirds and 169 over 36. So we need to make these common denominators. Looks like I need to make this 10 thirds into something over 36. Since 3 times 12 is 36, 10 times 12 would be 120. And then we need to add the 169 over 36. If I added correctly, I got 289 over 36. So now that it's factored and added, now we need to take the square root of both sides. And I don't know if you recognize that 289 is also a perfect square, as is 36. So I go over here. So then I end up with x minus 13 over 6 equals plus minus 17 over 6. So now since I don't have any roots, I can actually go ahead and get these two answers. So I'm going to take this negative 13 sixths and add it to both sides. So I have 13 sixths plus 17 sixths for one answer, and then I have 13 sixths minus 17 sixths for the other answer, and we can actually do this math. And if I did this right, I get 30 over 6, which turns out to be just 5 as one answer. And if I subtract this, I get negative 4 sixths, so the other answer is negative 2 thirds. So those are the two answers for the quadratic. One last example before this long video is done. Again, got to get rid of this x squared coefficient, so we divide it out. And let's see if I can remember to keep the 9/5 together this time. So we have x squared minus 2x, leaving a space, equals a negative 9/5. And then we're going to add the same thing to both sides. So this completing the square doesn't look too bad. Half of 2 is 1, and 1 squared is 1. Since I'm going to be adding a 1 over here, and we need it to be in fifths, why don't we just write the 1 as 5/5, and then we'll have common denominators right away. Factoring the trinomial square, x minus 1 quantity squared equals negative 9 plus 5 is negative 4/5. So we are ready to take the square root of both sides, and we notice that we have a negative sign. So we have x minus 1 equals plus minus, and I'm going to split them up here because that helps me see it, of negative 4 over square root 5. Well, the 4 is a perfect square, so let's do that. So we have 2, and the square root of that negative 1 is I, and we're still over square root 5. We need to rationalize the denominator. I will be adding a 1 to both sides, but I just thought I'd work with this fraction. So let's multiply by the square root of 5 over square root 5, and let's go ahead and add the 1 to both sides. So my grand answer then, I have 1 plus minus 2i square root 5 all over 5. And yes, you do get imaginary answers, and we can work with that now. So a ton of steps there. This video might be good to watch a couple times and make sure we get all these steps. It's taking everything together and putting it into one problem. So have fun with math.